Hello everyone, we are from Group 13, ECH 3120, Chemical Engineering Thermodynamics. Today, we are going to review short summary of Thermodynamics Web. Five contents we are going to cover. First, Thermodynamics Web. Second, Maxwell relation. Third, secondary relations. Fourth, three general sources of Thermodynamics Web. The last one is usage of thermodynamic web. Now let's talk about thermodynamic web. It relates partial derivatives of temperature, pressure, entropy, and volume. Moreover, it provides 12 permutations of partial derivatives between these property relationships to make a complete set. Moreover, the terms are related to other terms using either Saccharin rule or Maxwell relations. Now let us move on to the content 2, which is Maxwell relations. As what I mentioned earlier, Maxwell relation is one of the relations that used to connect each term in thermodynamic web. In general, Maxwell relation is thermodynamic equation which establish the relation between various thermodynamic quantity in equilibrium thermodynamics. It is derived by applying inverse reciprocity to the derivative of the equations of that. When we apply Maxwell relations, any of the terms on one side of the double arrow of a Maxwell relation can be replaced by terms on the other side. So the figures shown beside are the 4 Maxwell relations that will be used in thermodynamic web. Let us talk about the cyclic relations. Cyclic relation is a formula which relates partial derivatives of 3 independent variables. When we apply cyclic relations in thermodynamic web, the terms at the origins can be replaced by the product of 2 terms at the other ends of arrow. For example, you may refer to the figure. At the top of the thermodynamic web, negative delta P over delta V can be replaced by the product of delta P over delta S and delta S over delta V. In addition, there are 3 general sources that will be used in thermodynamic web. The first one is derivative of equations of state. Second, the thermal expansion coefficient and the isothermal compressibility. The last one is the heat capacity at constant pressure and at constant volume.
Now we have come to the last part of the video, which is the usage of thermodynamic web. In general, thermodynamic web is used to solve the thermodynamic problem involving immeasurable values. In thermodynamic web, cyclic relations and Maxwell relations are represented by the icon that show on the top right of the figure. So how do we use thermodynamic web to solve the problem? For example, when you are given pressure and volumes and you are required to find the temperature, you may follow the path from negative delta P over delta V, which is on the top of the thermodynamic web, until the delta T over delta V. So you may solve the problems by following the path of the arrow. That's all for this video.